Hello everyone, once again welcome to Mathline channel. In this channel you will be getting a basic maths lesson every week. Those who have not watched the previous lessons, please watch from the beginning and continue watching. Also share each and every video of Mathline as much as possible to the students of all standard. So let us start today's lesson with a new topic, that is properties of secants. You have studied what a secant is. It is a line intersecting the circle at two distinct points. Here we will study some important properties of secants. See the figure, first figure, you can see two secants intersecting at a point P in the exterior of the circle. And in the second figure, you can see again two secants intersecting at a point P in the interior of the circle. In both the cases, there are new segments formed by the secants and the points on the circle in which they intersect. There is a relation between them. The relation is that in both the cases, P Q into P R equal to P A into P B. Start from the point of intersection only. Here also same. PQ into PR equal to PA into PB. The product of the segment, how it is to be taken in the same order. P start from P. PQ into PR equal to PA into PB. Here also same. PQ into PR equal to PA into PB. That is the relation between the segments formed. Now, there is a relation between the angle found by the secants at the point P, that is at the point of intersection, and the intercepted arcs formed by them. Which are the two intercepted arcs? That is BR and AQ. The minor arc. BR and AQ are the intercepted arc formed by these secants, and angle formed at the exterior by the secant is angle APQ or angle BPR, any way you can name. Measure of that angle, if it is in the exterior, measure of angle APQ equal to half into measure of arc BR minus measure of arc AQ. If it is in the exterior, the point of intersection is in the exterior and angle formed at that point is equal to half the difference of the measures of the intercepted arc BR and AQ. Clear? If it is in the exterior. If it is in the interior, angle APQ equal to, here also you have to take the intercepted arc, that is PAQ and QB. They are sum and half of that. So what is APQ? Half of bracket measure of arc AQ plus measure of arc QB. If you are taking this angle, that is BPQ equal to half measure of arc BQ plus, measure of arc BR plus measure of arc AQ. The corresponding intercepted arcs you have to take. If you take angle APR, measure of arc AR and measure of arc BQ. If you are taking measure of angle BPR, measure of arc BR and measure of arc QP you have to take. So when two secants intersect in the interior, the angle formed at the point of intersection will be half the sum of measures of the intercepted arcs. Clear? APR equal to half measure of arc AR plus QB. If it is BPR, half measure of arc BR plus QA. Clear the difference? The relation between the product of segment is same in both the cases, but measure of the angle formed at the point of intersection will be, in the case of if it is exterior, it will be the half the difference of the intercepted arc. If it is in the interior, half the sum of the intercepted arc. Clear? Now see the third figure. Here the intersection, here exterior, here interior, and here the point of the circle. Then one of the secant become tangent if it is like that. If the point of intersection is on the circle, one will be secant and the other will be tangent at the point P. Clear? In that case only one intercepted arc will be there. So here there is no question of the relation between the segments formed by them, but the relation of the angle formed by them. So in this case, angle APB equal to half the measure of arc AXP. Clear? Angle, here one side, one line is secant through the point P and one line is tangent through the point P. Then the angle between them equal to half the measure of arc AXP. Clear? APB equal to half measure of arc AXP. Which is this case? When the point of intersection is on the circle, then one of the line become tangent. You can take the other side also. Half the measure of this major arc will be, suppose there is a point C here, measure of angle APC. Clear? Understood? The same case it is. One secant and one tangent. Understood? When the point of intersection is on the circle, then the measure of the angle formed by them is half the measure of the intercepted arc. It is very important, this property. Here, this angle is, one side of the angle is secant and the other side of the angle is tangent. Then the measure of the angle is half the measure of intercepted arc. This property is known as tangent secant property or tangent secant theorem. Why? Because the one side of the angle is secant and the other side of the angle is tangent. Clear? Now here also the intersecting point is in the exterior. But what is the difference from the first figure? Here one line is tangent and the other line is secant. Clear? Point P, that is the point of intersection, is in the exterior, but one line is secant and the other line is tangent. In this, the relation between the segments is PA into PB equal to PT square. Here only one segment is there. So what is that? PA into PB equal to PT square. And the angle, that is angle APT, equal to half the difference of the intercepted arc. What is the intercepted arc here? BXT and AYT. These are the intercepted arc by this secant or by this angle found by the secant. Clear? So in this case, angle APT equal to half into measure of arc BXT minus measure of arc AYT. Clear? Understood the relation? It is similar relation, the angle, but the segment relation is different because only one segment is there because one is tangent. Clear? So these are some important properties of secant. Clear? The first figure, two secants intersecting in the exterior. Second figure, two secants intersecting in the interior. Here, two lines intersecting in the point of the circle. In that case, one is secant and other is tangent. Here, two lines intersecting in the exterior. One line is secant and other line is tangent. So relation understood here. PA into PB equal to PQ into PR. Here also same. PA into PB equal to PQ into PR. The segments. And angle QPA equal to half difference of, that is BR minus AQ. Here APR equal to half measure of arc BQ plus measure of arc AR. And here one line is tangent and other line is secant. Then measure of the angle is half the measure of intercepted arc. That is angle APB equal to half the measure of arc AXP. And in this case, PT is the tangent and PAB is the secant. Therefore, PA angle P or angle APT equal to half of measure of arc BXT minus measure of arc AYT. These are the relations. Understood? That is the end of today's lesson. Thank you for watching this lesson. Please watch each and every video from beginning to end for better understanding. See you next week with a new topic. Have a nice day. Bye bye. See you.